Welcome. In today's video, we'll be looking at the speed of light and also refractive index. So for a start, most of you appreciate that light is an electromagnetic wave. It travels through vacuum at a speed of 299,792,458 meters per second. That's extremely fast. For the purpose of VCE physics, we round that to 3.0 by 10 to the 8 meters per second. The speed of light is used so often in physics, it's given its own symbol, c. The symbol c stands for celerity, and it's Latin for the term swift or quick. To give you some idea of how quick the speed of light is, consider the following. The speed of light travelling at 3 by 10 to the 8 meters per second, which is the same as 300,000 kilometers per second, can travel around the globe once, twice, three times, 4, 5, 6, 7 and a half times. In 1 second. That is extremely fast. 7.5 times around the globe in 1 second. However, the speed of light isn't constant in all materials, or what we call mediums. Different mediums or materials have a unique what we call optical density. And this feature impacts the speed or the velocity of the different mediums. Consider the following speeds of light for each of the following mediums. So here we have the different speeds of light in the various mediums. Light travels in air at 3.0 by 10 to the 8 meters per second, which is effectively the same as a vacuum. In ice, light travels at 2.31 by 10 to the 8, water 2.25 by 10 to the 8, glass 2.0 by 10 to the 8, and in diamond, light has been slowed down significantly to a value of 1.25 by 10 to the 8 meters per second. Now, describing these different mediums by the speeds of light can be a little bit challenging, so we use a quantity called the refractive index. And like all indexes, it's a number that is unitless that describes a ratio of two quantities. And the refractive index of a particular material is simply the speed of light in air divided by the speed of light in that material. So the refractive index, which is given the symbol m, is the speed of light, which is 3.0 by 10 to the 8 meters per second, divided by the speed of light in the given material. So that's an equation we can use to calculate the refractive index. So in the case of air, this is very simple. The refractive index of air is the speed of light in air divided by the speed of light in air. Now that obviously has a refractive index of 1. It's a very simple calculation. So that's our reference index. If a material has a refractive index of 1, it means that light is traveling through air. The material is air. Let's consider now the following refractive indices. So the refractive index for ice is going to again be the speed of light in air divided by the speed of light of that material, which was 2.31 by 10 to the 8. Same for water. To calculate the refractive index of glass. And for our final example, we're looking for the refractive index of diamond. Now, using my calculator, we can complete the following calculations. So there we have it. We have the refractive index of air as 1.0. The refractive index of ice is 1.3. The refractive index of water is 1.33. Of glass is 1.5 and of diamond is 2.4. You notice that as the velocities or speed of the light decrease, the refractive index increases. So the higher the refractive index, the slower the velocity, and the lower the refractive index, the higher the velocity. And this calculation is purely being made from this equation, where the refractive index of the material is equal to the speed of light, c, 3.0 by 10 to the 8, divided by v, the speed of light in that given material. Let's consider a couple of examples. Example number 1. Let's consider flint glass. Now, flint glass is a special glass. The speed of light in flint glass is 1.86 by 10 to the 8 meters per second. And we're asked to calculate its refractive index. Here's our equation. Refractive index N equals the speed of light in air C divided by the speed of light in the medium V. N equals C over V. Speed of light in air was 3.0 by 10 to the 8. The velocity of light in flint glass is 1.86 by 10 to the power of 8. And that calculates to a refractive index of 1.61 as my final answer. Now, of course, this value has no unit because it is a speed in meters per second divided by a speed in meters per second. So effectively, this is meters per second being divided by meters per second. The numerator and denominator units cancel out to leave me with a unitless quantity. So the answer to our question, flint glass with the speed of light of 1.86 by 10 to the 8 meters per second has a refractive index of 1.61. Example number 2. Let's consider alcohol. It has a refractive index of 1.35. And I would like to find out what is the speed of light in alcohol. Let's go to our equation. This time, instead of trying to find N, the refractive index, we want to calculate V, the speed of light in the material. So V is equal to, when we cover over V, we're left with C over N. So V is equal to C over N. We now have our equation. Let's substitute in the values. C, the speed of light in air, was 3.0 by 10 to the 8. And N, the refractive index, was 1.35. That gives me a velocity of 2.2 by 10 to the 8 meters per second.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.